Okay, so this video is about the classes of organic compounds known as the alkenes and alkynes. So alkenes and alkynes, as you can sort of tell from the name, are going to be somewhat similar to alkanes. And the major similarity is that they are entirely hydrocarbon, so they're only made of carbon and hydrogen. The difference is that while alkanes have no functional group in all single bonds between carbons and hydrogens, the alkenes have at least one carbon-to-carbon double bond, and the alkynes have at least one carbon-to-carbon triple bond. The name of the functional group itself, so this double bond, if you saw this in a larger organic molecule, we'd refer to that as the alkenyl group, and this is called an alkynyl group. In the same way that when we talk about methyl groups or ethyl groups, we can call them alkyl groups. It's not really a functional group, but when there's a side branch that is alkane, you call it an alkyl group. So these are called alkenyl and alkynyl. General formulas, if this is the alkane, CnH2n plus 2. The alkenes are CnH2n, so they always have two fewer hydrogen than the corresponding alkane. And the alkyne, because of the two double bonds, they actually are missing four hydrogens, so they end up with CnH2n minus 2. So as specific examples, we've got ethane, we've got ethene, and we've got ethyne. So the eth corresponds to the two carbons, and you can see the naming suffix, the ane versus ene versus ine, refers to the functional group or lack thereof. In terms of naming considerations, the only thing to be aware of is that when you have one of these functional groups, the alkenyl or the alkynyl groups, they're between two carbons. So that's a little bit trickier in terms of numbering. What number do you pick? This double bond, for example, is between the 1 and the 2, as is this one. So when a number is required, you should kind of be grasping that the general rule of thumb is always pick the lower number. So if you have a bigger alkene, and like when there's 4 carbons, and so you could either have a double bond between the 1 and the 2 or the 2 and the 3. If it's between the 1 and the 2, you would call it 1 and then ene. And if it's between the 2 and the 3, you would call it 2 ene. So you're always going to pick the lower of the two numbers whenever you have to number these things. But obviously these ones are so small, there's only one position possible for that carbon-to-carbon double or triple bond, so you don't need to number it, and they're just called ethene and ethyne. A couple other small considerations for these groups. They are more reactive than alkanes, and that's because the additional bonds, those second and third bonds, are more reactive than the original carbon-to-carbon single bonds. For the HL class, you'd point out that the pi bonds are weaker than the sigma bonds, but for SL, it's just the idea that those extra bonds are a little bit weaker and therefore more reactive. These groups still combust readily, like the alkanes do, but they also have a lot of other reactions that we'll look at. And specifically for the alkenes, we're going to look at a variety of addition reactions that they will undergo. In terms of isomers, while you can obviously do isomers by moving around the carbon-to-carbon double bond or moving around the carbon chain itself, like we've done before, with alkenes and also alkynes, but more importantly, I think for the IB exam, the alkenes, you can also draw them, structural isomers, as cycloalkanes. And so cycloalkanes are not a group that you have to name, but you should be aware of them as that they exist, and that actually if you take the same exact formula, so in this first case, if I take C3H6, I can draw it with one carbon-to-carbon double bond and I have propene, or I can draw it as a ring, and this would be called cyclopropane. So both of these molecules exist, and they are structural isomers of each other, and they're really quite different. Again, down here, this one would be called 1-butene or but-1-ene. So two different ways to number this. 1-butene or but-1-ene. Those are both acceptable names for this molecule. Notice it looks like it's between the 3 and the 4 carbon, but I should always number giving the lowest numbers possible. So this is the number 1 carbon, 1, 2, 3, 4. And so since it's between 1 and 2, I name that functional group as being on the 1. So either 1-butene or but-1-ene. You can put the numbers within the name. Over here, though, this is called cyclobutane. And they both are C4H8, so they are technically structural isomers of one another. So normally when you get a question and they say draw all the structural isomers, you probably focus on doing things like this, where you could move this double bond down. Maybe you could rearrange this carbon chain to make the longest chain 3 with a methyl group off the middle carbon. But sometimes they'll ask you to look beyond just the alkenes, and can you come up with any other groups that are isomers? And so the cycloalkanes are isomers of the alkenes, just something to be aware of. In terms of physical properties, alkenes, alkynes, alkanes, they're all just hydrocarbon, so they are very much nonpolar. So they have very, very low boiling points and melting points. The small ones are going to be gases or extremely volatile liquids. And I'll leave these other quick questions for class. They're just some things to think about in terms of bond angle and boiling points that sometimes get asked. Okay, so that's the alkenes and the alkynes.